This work starts with the understanding that New Zealand's estuaries are very heavily polluted with sediment, and that's typically fine sediment, muds and clays. And that began about a couple of hundred years ago when we started clearing trees from the landscape. And it continues today with things like poor agricultural and forestry management practice, greenfields, development, urbanisation, road building, that kind of thing. The problem itself of fine sediment pollution is manifest in a number of ways. For instance, waters are more turbid now than they previously would have been hundreds of years ago. And also we see sandy habitats progressively smothered by mud from the runoff from the catchment. That can have a number of ecological effects. The model that I've developed, it predicts how an estuary will evolve as land use intensification and change occurs in the surrounding catchment. So what we can do with the model is we can predict the future state and health of the estuarine ecosystem under different development scenarios, so we can choose the best development scenario. And we can also use it to design and to locate in the catchment the best place to put sediment and contaminant mitigation options, and that way give the desired environmental outcomes in the harbour. Now, for managing the sediment problem today, what we need to know is where in the catchment sediment comes from, and knowing that we can properly target management intervention. And some of that intervention might be things like better riparian planting around the margins of streams, or it might be better construction methods or different agricultural practice, pasture management, for example. So we need to be more precise about this, and we need to know exactly where in the catchment sediment comes from that is affecting the most valuable parts of the harbour, and that might be valuable from an ecological point of view or a human amenity point of view. So what we've been doing here is creating a so-called seamless composite model, which, if you like, is a collection of these smaller individual models which we link together in physically based ways, which means we use our understanding of the physics of the processes to join these models together, and furthermore to get them to run at this long 100-year timescale. One thing we've discovered is that you can sometimes spend all the money you like on stormwater treatment and it's still not going to have the necessary, the desired effects in the estuary. Stormwater treatment is typically a device or a series of devices that removes sediments and metals from the stormwater runoff. What our model shows is that they're often not nearly effective enough to prevent metals reaching toxic levels in the estuary sediments. And what that means is, instead of focusing on the stormwater treatment, you need to shift your focus to preventing generation of contaminants at source.